Yeah, in the meantime, hi everyone, I'm Himanshu Tyagi. I'm just like the previous speaker, I'm also an academic. I'm a professor at Indian Institute of Science in Bangalore, and I am also a co-founder for WitnessChain. And a short thing is that this talk will be about WitnessChain and what we are building on EigenLayer. We're sort of restaking maxis, and today in Sriram's talk, he flashed different applications that are coming to EigenLayer. We're building two of those. We are building the Watchover Network, and we are building a proof of location, which we call no lock, and I'll speak about both those things once my slides are up here. Uh, yeah, in the meantime, maybe we can chat about something else. Oh, great. So, yeah, so just a bit about WitnessChain profile. So it's a academic blockchain research team turned blockchain builders. My co-founder Pramod is a professor at Princeton, and he is a consensus researcher. Ranveer just completed his PhD in scaling blockchains, and he's my second co-founder, and I'm the third one. And we raised funds last year around June, and we started with building infra proofs, but then I'll talk about what those were. And then this EigenLayer event happened, and we paused and reoriented, and now all we do is build AVSs and operator services. Right, so the reason we are doing this is that something very important happened over the last year, I would say, maybe slightly longer, is that we all agreed in Ethereum ecosystem that the road to hyperscaling will go through rollups, and all this excitement will happen on rollups. So given that all these different ideas we were developing in sharding, in plasma chains, and stateless blockchains can all be taken and now brought to rollups. So builders like us, the researchers like us started doing that. And this big economic opportunity which will come when all these ideas come to rollups, when more and more applications come to rollups, is huge. But with great opportunities, one has great risks. And the risk in this case is the risk because of risky assets sitting on rollups. And so it's very important to think of how would these assets be secured. And the answer today is there's a reactive basic security on rollups. So if something goes wrong, then someone can raise an alarm, provided the rollup has a fraud proof, provided the rollup has a dispute resolution mechanism. Today, Arbitrum has announced, not today, but recently Arbitrum has announced its Bolt protocol, which is its fraud resolution, which is its fraud proof protocol. And hopefully others will also come up with it. But even with this fraud proofs, the whole security system is reactive. Once a fraud happens, once something happens, then someone can raise an alarm and have dispute resolution. What we believe is that from this reactive, we have to move from security and watching in normal path. There is this layer which is missing in the current rollup architecture. We need a module called watchtowers, which are watching all the time in normal path. Okay, and that is what has to be designed. You have to design economic models, and you have to design proof systems which incentivizes watchtowers to watch in the normal path when things are not going wrong, and not only when things go wrong and that thing. And this is the problem that WitnessChain is solving. Our watchtower network is we are building a network of watchtowers which will be watching all the time in normal path, and this will be the first line of defense for rollups. What do I mean by that? The current security is second line of defense once things go wrong. This is something which is working all the time when things are not going wrong. And this watchtower network we are building with three key properties. One is it has to be trust-free. I'll speak about these properties in the next few slides. It has to be decentralized, and it has to be programmable. So what do I mean by trust-free? What do I mean by trust-free? Suppose you get a guard to watch something, and you're paying the guard the salary. The best answer guard will have is, okay, nothing is going wrong, because things go wrong very rarely, and you keep paying salary to this guard. So you have to make sure that in the normal time, when you're paying that salary, actually the guard is doing its work. So for that, we design a cryptographic proof called proof of diligence, where we extract the intermediate state from the blocks and batch it up with and append to it a transaction inclusion proof, and that's a cryptographic proof we develop. And then all these watchtowers regularly mine diligence bounties, which shows that they have been doing their work. And we design an incentive system which also makes sure that the watchtowers are watching each other. Otherwise, there's this loop about who watches the watchtowers. So that's the system that we have designed. And so you don't have to trust anything. You don't have to trust that a existing RPC node is your watcher because it's incentivized to do so, or because some applications are watchers because they have their own incentive. These guys will be tied to a cryptographic proof which will incentivize them to watch. This is the first part. So the Watchtower network is trust-free. You just have to trust the cryptographic primitive. Don't have to trust the watchtowers themselves. Second proof, which is something very cool, is that it's decentralized. Now, decentralization is a core ethic for Ethereum. However, it's always indirect. When we think of decentralization, it comes to some economic incentives or some external thing. What we did here was we took a more ground-up approach. We tried to ensure physical decentralization of the Watchtower network. We ensure that actually they are in different geographical locations. And how do we do this? We do this by measuring internet delays to the Watchtower network, to the nodes. And once you have delays with the understanding of internet topology, you can convert that into distances. Okay, that's some knowledge that we have developed. All right, so these challenges are saying that this Watchtower network is somewhat this distance away from me. So you got those distances. Now it's some basic trigonometry, take intersection of circles and check if the Watchtower is there. Yeah, so that one can do, but then these guys can cheat. So what we did is we enhanced that basic trigonometry with some Byzantine fault tolerance to develop a proof of location, which we call no-lock, which can actually check for physical location of watchtowers. And even though watchtowers may set up VPN services, they may set up someone can set up a validator node, a watchtower node in, let's say, in Europe somewhere, but claim the location to be in the US using a VPN node. This proof can check that, and it can cache those things. So the Watchtower network is physically decentralized. You can ensure that the watchtowers are spread across 3 countries, for example. And the last property, closer to ground, is that this Watchtower network is programmable, which means that these different applications that we were talking about on rollups, which will be using this Watchtower network, they can access the output of the Watchtower network through what we call a transaction tracer API, where they can submit the hash of their transaction and see the journey of that transaction and get confirmation about status confirmation about which watchtowers have watched what about this transaction and if some alarm is raised or not. So that's what it is. It's a Watchtower network which is trust-free, decentralized, and programmable. And this sits in the eigenlayer ecosystem. The way it works is that the operator installs this. All right, let me see the point. Yeah, the operator installs this client, and then the stakers, once this client is installed, then the stakers can start providing additional security to all the applications. Watchtower is the baseline thing, but we can provide additional security beyond it. We hope to integrate with many other exciting applications coming to EigenLayer, for instance, the other interoperability security offerings, and add more and more services to the Watchtower network through that. And as I said, this no-lock, which is a part of the Watchtower network, is also the proof of location, which is available as a standalone primitive for EigenLayer AVS builders, where the operators can show the decentralization of their location. And in fact, we hope that this goes beyond just this, and we hope that this is the tool which ultimately ensures that Ethereum is super decentralized, which incentivizes this individual validator runners to show that they are actually in different locations. And then AVS system can come and incentivize operators to be spread out across multiple geographies using this proof of location. Right, so we have been building this roughly for about a year now. Many things are up and running, and formally this Watchtower network, at least the testnet phase 1, will be going live in December, and we hope many of you can participate on this. And this is just the beginning. This is just the beginning. A lot of tech can be built on it. For example, one thing which is down our roadmap is rotation of watchtowers. Watchtowers provide strong security because the watchtowers are not always attached to the same rollup. We rotate the watchtowers between rollups, and that rotation client uses some stateless blockchain techniques and all that. So a lot of tech being built, and this will become the first line of defense for rollups. Follow us on Twitter and watch for new updates. Thank you very much.